So now we're going to talk about one-step addition equations. And what I mean by one-step addition equations is equations where a number is being added to our variable. So keep in mind, when you have an equation, it means that there's something on one side of your equation and equals and something on the other side. In other words, to have an equation, you must have an equals mark joining two sides. Now in this particular equation we have 4 positives being added to x, and that equals 6. Now I know you can do this in your head, but I want to use a basic problem to go through the process of understanding equations. So I'm going to demonstrate x plus 4 equals 6 on the balance beam picture over to the right. So we have a big old X in red, and I'm going to draw 4 positive chips beside my x. So this is a visual representation of x plus 4 on the left-hand side of a balance beam. On the right-hand side I have 6 positives. So I'm drawing in 6 blue chips. I'll use blue to be my positive chips. Now, the reason we use a balance beam as our model is to illustrate the idea that the two sides have to be equal or balanced. So equals lets us know that the two sides have the same amount on them, or the same value. If one side has more of a value, or has more on it, then this will no longer be equals. It would actually be an inequality. One side would be bigger than the other. So the fact that we have an equals means the two sides are equal to each other, they have the same value, or they're balanced, however you want to think about it. So what we're going to do is we want to discover what's inside of our x. You can think of your x as a bag. So this is a bag, and it has some amount of chips in it that are either positive or negative, and we're going to figure out what's inside that bag. So whatever's inside that bag has to give me the same value on the left-hand side of my balance beam as the right-hand side. So what's in that bag? It's kind of obvious, right? 2 positives have to be inside that bag in order for us to have 6 on one side and 6 on the other. Now, the way we can figure out that there's 2 positives inside that bag is by using our opposite property. So what we're going to do is we're going to get rid of all the chips that are beside our x. In other words, we want to isolate the variable x. We want to get it all by itself. Once it's all by itself, we can look over on the right-hand side and we'll be able to see whatever's on the right-hand side is what's inside our bag, or inside of our x. So the way that we get rid of 4 positives is we add 4 negatives. What happens every time you add a positive to a negative? You end up with 0, right? So adding 4 negatives to those 4 positives gives us 0. Now, I've just put some extra chips over on the left-hand side, so everything's out of balance. So what am I going to have to do to keep this balance beam in balance? I'm going to have to do the exact same thing to the right side that I did to the left side. So I'm going to have to add 4 negatives to my right side as well to keep the equation balanced, to keep the equation equals, which means it's going to be balanced. So again, all pairs of a negative and positive will equal 0, because negative 1 plus positive 1 equals 0. So what I'm left with is my x over on the left-hand side and 2 positives over on the right-hand side. And this blue line here represents equal. The fact that the two sides are balanced stands for equals. Okay, so the way I'm going to show this with my steps is I'm going to demonstrate what happens by adding the opposite to both sides. And these are the steps that I expect you to show me. So you need to show me what you're actually doing to both sides. We're adding 4 negatives to both sides. The reason we do that is to get rid of the 4 positives that are being added to x. So 4 plus negative 4 equals 0. I'm adding straight down right now, bringing everything straight down. And I bring my equals straight down, and then 6 plus negative 4 equals 2, bringing everything straight down. Okay, so I end up with x plus 0 equals 2. Now, x plus 0 can be added together. So x plus 0 is x. Bring my equals down and bring my 2 down, so x equals 2. This is the process we'll go through in solving all equations. when we're dealing with addition. So the process is we first add the opposite to the side with x of whatever is being added to x. We're adding 4 positives, so we add 4 negatives to the side with x. Then we do the same thing to the other side to keep the equation balanced. Then we simplify everything and we'll come up with our final answer. Now this step right here, x plus 0 equals 2, you do not have to write that step. You can go straight to writing x equals 2. A lot of people like to write that step. It helps them. It completely depends on your learning style. Let's look at another example. X minus 3 equals negative 7. I'm going to change this to x plus negative 3 equals negative 7. So we're going to change all subtraction to addition by keep change opposite, or adding the opposite, and that will help us know what sign we have on the number that's being added to x. So here we have 3 negatives, I'll use red for negatives, beside my x, and 7 negatives on the right hand side of my equation. So what do we need to do in order to get that x by itself? We're going to add the opposite, right? We want to get rid of those 3 negatives, so what are we going to add? 3 positives, right? So those 3 positives will cancel those 3 negatives. So what do we have to do to the other side to keep this equation balanced? We have to add 3 positives on that side as well. And all 0 pairs will cancel each other. So on the left hand side, we're left with our x. Everything's balanced, so we have an equals, and then what do we have on the right hand side? We have negative 1, 2, 3, 4, negative 4. So the steps that we'll show in our equation, obviously you're not going to be drawing these pictures. The picture is just to help you understand the process. We're going to be getting rid of the negative 3 by adding positive 3 to it. And since we add 3 on the left side, we have to add it on the right side to keep our equation balanced. Next we simplify. We bring the x down, we bring the plus down, negative 3 plus positive 3 is 0. We bring the equals down, negative 7 plus 3 is 4, negative 4, so we bring the negative 4 down. We simplify x plus 0 to equal x, bring down our equals, and bring down our negative 4, so x equals negative 4. Now, one thing we can do in both of these equations that we've looked at is we can check our answers to see if they're correct. So let me show you check steps. Let's get back to the original equation, x plus 4 equals 6. We found that x equals 2. So what I'm going to do is I put a little check here to show that this is my check step. That's a check and a colon. I'm going to put 2 in the place of x. I'm going to substitute 2 for the variable it equals and just rewrite the rest of the equation. Is that a true statement? Does 2 plus 4 equal 6? Yes. Therefore, I know my answer is correct. So one wonderful thing about this unit on equations is that you can check your answers. So let's do our check step for this additional problem at the top. I'm going to substitute negative 4 in the place of x. Now I'm going to write my original equation in case I messed up when I changed subtraction to addition. So negative 4 minus 3 equals negative 7. I'm going to change that to negative 4 plus negative 3 equals negative 7. Is that a true statement? Yes. Negative 7 does equal negative 7. So now I'd like you to try a few problems after we review the big picture of what we're going to be doing. So we're going to be using inverse properties to get x by itself. We're going to be using inverse properties to get x by itself. And inverse properties are the properties that undo each other. So we learned that with addition, the inverse property of addition is the opposite property, or the opposite property is what you work with addition. So anytime you add two numbers that are opposites, what do you always get? You always get 0, right? So we use the opposite property in our very first step in both of our equations in order to get x by itself. We use the opposite property here by adding negative 4, and in this other equation we used the opposite property by adding positive 3. Now, we will see later on that when we're dealing with multiplication, we work with reciprocals. We're going to work with the reciprocal property, or the multiplicative inverse. And we'll see later in this lesson that whenever we're squaring something, the inverse is square root. And we talked about that. Squaring and square roots undo each other. They're inverse operations. Or if something is being square rooted, so if our variable is being square rooted, we're going to square it to get x by itself. And of course, whatever we do to one side, we have to do to the other side. So whatever inverse operation you perform to the side with the x, you must also do the same to the other side to keep the equation balanced or equal. Okay? So now try these two problems and show all your steps, including your check steps, just like I went over with you. Here are the steps for the two problems that you just completed. Again, the one step that you can leave out is this step, but I need to see all the other steps. So now let's move on and try this problem. Now we're going to be applying decimals, negatives, and equations, and work on these all together. So what should I do first? You thinking we should change this subtraction to addition? You are absolutely right. It's always the first thing you do if you have a subtraction equation. Change it to an addition equation. So what do you think we do next? Add positive 3.2 to that negative 3.2 to cancel it out. And if we do it to one side, we have to do it to the other. Now we're going to simplify both sides. Now we have a negative plus a positive, which means we have to subtract since they're different signs, even though it's addition. So we're going to subtract. 9 minus 2 is 7. Lining up the decimals, 7 minus 3 is 4. And is our answer positive or negative? It's negative, right? Because we have more negatives than we do positives. So x equals negative 4.7. And we could also check this, but we're going to go ahead and move on. Sometimes you're going to have problems where you have like terms that you need to add together before you get started. So in this example, we have 5 1/3 plus g plus negative 2 1/6 equals negative 9. So we can't really tell what one number is being added to g because we have two numbers that are being added to g. So we need to go ahead and add those two numbers together before we start actually solving the problem. When I add together 5 1/3 plus negative 2 1/6, I'm actually subtracting and keeping the sign of whichever I have more of, which is positives, and I get 3 1/6. So I end up simplifying the equation to g plus 3 1/6 equals negative 9. Now I'm going to add the opposite of positive 3 1/6, which is negative 3 1/6, to both sides. Now this makes the problem pretty easy because on the left-hand side, we end up with g because the 3 1/6 cancel out, and negative 9 plus negative 3 is negative 12 1/6, and that's our final answer. So go ahead and try each of these problems, and you need to show your steps and your check steps.